Hello everyone, I am Jagdish Patel, Assistant Professor, Sandeep Foundation, Nasik. The name of subject is Broadband Communication System. This one is Unit 6, Satellite Communication, Link Design. Lecture number 1, in which we are going to see Introduction to Satellite Communication. I am having 12 years of teaching experience, specialization in digital communication. Now, communication satellite. A communication satellite can be looked upon as a large microwave repeaters. It contains several transponders which listen to some portion of spectrum, amplifies the incoming signal and broadcast it in another frequency to avoid interfacing with incoming signals. Motivation to use satellite. This one is Atlantic links. Here these are the two antennas which are fitted on the ground, and the transmission or the communication between these two antennas over 150-kilometer high towers can be taken place in such a manner. Communication satellite. Now satellite mission. Satellite missions are nothing but this one is a graph which explains us how much the satellite different types of satellites can be used on the earth. So the maximum percentage is used for communication. After that, the earth science uh, or meteorology 5%, astrophysics, space physics 5%, earth observation, remote sensing 5%, military civilization or civilian 6%, and navigation 7%, and the rest remaining is others, that is 6%. So these are the proportion of the earth which are used in terms of percentage for different applications. Satellite microwave transmission. Satellite can relay signals over a long distance. Geostationary satellite remains above the equator at the height of about 22,300 miles, travel around the earth in exactly the same time the earth takes to rotate. Satellite communication system. This one is a components of satellite communication system. It consists of a satellite. After that, the signal is given to ground section, that is TT&C. Uplink. Earth stations are used for uplink and downlink frequencies. And this one is the coverage area where the satellite can cover to transmit the signal and to receive the signals. Space segment. Satellite launching phase. Transfer orbit phase. Deployed. Operation. TT&C means tracking, telemetry and command station. SSC means satellite control center, aka OCC means operation control center, SCF means satellite control facility, and retirement phase. Ground segment. Collection of facilities, users and applications. Ground segment. Collection of facilities, users and applications. This one is the antenna which through the two-way communication is there between the antennas and the satellite. After that, the signal is given to the users which is present at the home. Mobile station services, such as the signal is also given to the uh, person traveling in a car, plane, or we can say for navigation or for military applications. So these are the different applications where the satellite can use to provide the signals. We use to receive the signals and provide the signals. Types of satellite orbits. Based on the inclination I over the equatorial plane, equatorial orbit above the earth equator, that is I is equal to 0 degree. Polar orbit pass over both the poles, I is equal to 90 degree. Other orbits called inclined orbit, 0 degree, I less than 0 degree, I greater than 0 degree and less than 90 degree. Based on eccentricity, circular with center at the earth center, elliptical with one foci at earth center. Types of satellite based on network. Based on the satellite altitude, GEO, that is geostationary satellite, 36,000 km is equal to 22,300 miles, equatorial, high latency. MEO, that is medium earth orbit, high bandwidth, high power, high latency. LEO means low earth orbit, that is low power, low latency, more satellite, small footprint. VSAT, that is very small aperture satellite, private WAN. Satellite orbit. Geosynchronous orbit, 36,000 km above Earth, includes commercial and military communication. Satellite provides early warning of ballistic missile launching. Medium Earth orbit, that is MEO, from 5,000 to 15,000 km. They include navigation satellite GPS, Galileo GLONASS. Low Earth orbit, that is LEO, from 500 to 1000 km above the Earth, includes military intelligence satellite, weather satellite. So if you observe the structure as shown in figure, you can observe the satellite is orbiting around the Earth for different applications, different satellites having different ranges, or we can say different orbits. Satellite orbit for LEO, MEO, and GEO, there are different heights on which the satellites are revolving around the Earth. LEO, that is low Earth orbit, which is near to the Earth, 500 to 1000 km, 1.6 to 1.8 hours. MEO, that is medium Earth orbit, 8000 to 12,000 km, approximately 6 hours. GEO, that is geostationary, approximately 36,870 kilometers. So these are the distance where the satellite is orbiting. GEO, that is geostationary orbit, in an equatorial phase, orbital period 23 hours 56 minutes. Satellite appears to be stationary over any point on equator. Earth rotates at same speed as satellite. Radius of Earth r is equal to orbiting height plus radius of Earth. Average radius of Earth is 378.14 km. Three satellites can cover the Earth 120 degree apart. NGSO, that is non-geostationary orbits. Orbit should avoid van-aligned radiate beats. Region changes particles that can cause damage to satellite occurs at 2000 to 4000 km and 13,000 to 2500 km. LEO, MEO, HEO, GEO are the different orbits where the satellite orbiting it takes place. LEO, low Earth orbit, circular or inclined orbit with less than 1400 km altitude. Satellite travels across sky from horizon to horizon in 5 to 15 minutes. Need hands off. Earth station must track satellite or have omnidirectional antennas. Large constellations of satellite is needed for continuous communication. 66 satellite needed to cover Earth. Require complex architecture. Require tracking to the ground. LEO, that is high elliptical orbits, I is equal to 63.4 degree, are suitable to provide coverage at high altitude, include North Pole in the North Hemisphere, depends on satellite orbit, monoliot running, etc. Two or three satellites are sufficient for continuous time coverage of the service area. All traffic must be periodically transparent from the setting satellite to the rising satellite, that is satellite handover. This one is satellite orbits, MEO 43%, MEO 6%, GEO 43%, Monalia 2%, other 3%, and LEO 46%. Why satellite remains in orbit? With the help of gravitational force and inertial centripetal force, because of these two forces which act in opposite direction, the velocity of satellite remains constant over the Earth's surface. Advantages of satellite communication: can reach over large geographical area, flexible if transparent transponders, easy to install new circuits, circuit cost independent of distance, broadcasting possible, temporary application restoration, nice applications, mobile application, especially fill-in, terrestrial network bypass, provision of service to remote or underdeveloped areas, uses has control over own network, I for an multi-point standby possibilities. Disadvantage of satellite communication: large up for capital cost, space segment and launches, terrestrial break even distance expanding, not approximately size of Europe, interference and propagation delay, conjunction of frequencies and orbits. Why to use satellite? When the unique features of satellite communication make it attractive, when the cost are lower than the terrestrial routing, when it is the only solution. Example, communication to shift an aircraft, especially safety communication, TV services, contribution leak, direct to cable head, direct to home, data services, that is private network, overload traffic, delaying terrestrial investment, one for end diversity and special events. When to use terrestrial? PSTN satellite is becoming increasingly uneconomical for most trunk telephone networks, but there are still good reasons to use satellite for telephony, such as thin routes, diversity, very long distance traffic, and remote location. Land mobiles and personal communication in urban areas of development countries, new terrestrial infrastructure is likely to demonstrate. Example, GSM, etc. But satellite can provide fill in as terrestrial network as are implemented, also provide similar services in rural areas and undeveloped countries. Satellite communication: alternate vertical and horizontal polarization is widely used on satellite communication. This reduces the interference between programs on the same frequency band transmitted from adjacent satellite, allows for reduced angular separation between the satellites. So if you observe in the diagram, it will be clear to you. The above the earth satellite, geostationary satellite arc, in which they are doing the communication with the earth surface. So in this way, we have seen the introduction to the satellite, their applications, their advantages, different orbits and their disadvantages. Thank you.